Alright, so I'm back and I'm going to show you or run through the branchiomatic or branchial muscles of the shark operating on the gill arches and allowing the shark to respire, draw in water, expel in water, and also to feed on its prey, to close its mouth, for example. And the branchiomatic, as I said, the branchiomatic muscles can be categorized into constrictor groups and the levator group and the interarcuals. But the interarcuals, we won't study them in our specimens. They're not visible. They're not dissected. But some of the constrictors and levators are seen in our plastinated or actual formalin preserved wet specimens ng sharks, and therefore we should study them, and they have a possibility to appear in our exams and quizzes. Okay, so we start with the constrictor group. The constrictor group can be further subdivided into dorsal constrictors, dorsal to the gill slits, and then the ventral constrictors, located ventrally, ventral to the gill slits. Easy, right? But it gets difficult because these constrictor muscles have special names, especially those associated with the first two gill arches, the mandibular and hyoid arches. So the first dorsal constrictors are the following. These muscle here, located at the back of the eye, is the craniomaxillaris, and then located at the angle of the jaw, this large muscle at the angle of the jaw, that's the quadratobandibularis. And then it has a smaller sibling anterior to it, that's the preorbitalis. Together, the preorbitalis and the quadratobandibularis form the shark's adductor mandibular muscle. It's a very strong name. It's a strong muscle that allows the shark to close its mouth by elevating the mandible, adductor mandibular. But together, the craniomaxillaris, quadratobandibularis, preorbitalis, these are the dorsal constrictors of the gill arch 1, mandibular arch. The dorsal constrictor of the second arch, the hyoid arch, is this large muscle here, just before the first gill slit. This is the epihyoideus. In some texts, it's called the epihyoidean muscle. So that's the second dorsal constrictor muscle. And then the dorsal constrictors of the remaining arches, they don't have special names, fortunately for you. So these are just referred to as the dorsal branchial constrictors. You can call them that. And they are separated by vertical white lines of connective tissues called raphes. So dorsal branchial constrictors. The constrictors also have a ventral group, ventral constrictors. And the ventral constrictor associated with the mandibular arch is called the intermandibularis. It's the most superficial muscle just beneath the mandible. Intermandibularis. Okay. And then the ventral constrictor muscle associated with the second arch is the interhyoideus, and it's located deep to the intermandibularis. So you can see two layers of muscles there. The superficial is intermandibularis. The deeper one is the interhyoideus. Right, and then the ventral branchial constrictors have no special names for the remaining gill arches, just ventral branchial constrictors. So in general, the constrictor muscles, they are associated with the expiratory phase of respiration ng shark, allowing the shark to close its mouth and compress the gill pouches in order to force the inspired water out of the gill slits. So yun yung generic function ng mga dorsal and ventral constrictor muscles. Now we next go to the other category of or muscle groups of the branchial muscles. This one is levator maxillae superioris, the levator muscle associated with the mandibular arch. It's different from this one. That's right, that's craniomaxillaris. This one is levator maxillae superioris, a levator muscle. And then the second levator, hyoid levator, cannot be seen actually from our specimens. It's fused to the epihyoideus muscle, so you won't be able to identify it from our specimens. And the rest of the levator muscles, levators 3 to 6, are fused into a single structure near the pectoral girdle. So this would be already your scapular process. Let me pause for a bit and get our specimen for gill arches just to remind you. So this is our skeletal specimen for the shark, and you remember that the pectoral girdle looks like this. It has a coracoid bar and the scapular process projecting dorsally, right? And this would be the basals and radial pterygophores. And so you can see the scapular process is projecting dorsally, and if you skin the shark, it is already visible as this cartilage here. That would be the scapular process. Show you disarticulated. This is the disarticulated pectoral girdle. And that dorsally projecting cartilage is the scapular process. And as I was saying, the levators 3 to 6 are fused into a single muscle here near the scapular process. The triangular muscle peeking out from the dorsal branchial constrictors is the cucullaris muscle. And actually that's it for the branchiomeric musculature. And in general, the levator muscles serve to elevate the gill arches, and they are associated with the inspiratory phase of respiration, allowing the shark to draw in water into its oropharyngeal cavity. The next group of muscles are so-called hypobranchial muscles. They are beneath the gill region, hence hypobranchial. And they're discussed in separate to the branchiomeric muscles because it's believed that they have a different developmental origin, and they share a developmental origin with the trunk myotomes. Basically, these hypobranchial muscles are just anterior extensions of the hypaxial myotomes, right? So because of that separate origin of hypobranchials, they are discussed and categorized separately from the branchiomeric muscles, even though the hypobranchials still operate on the gill arches. And you only need to know 3 hypobranchial muscles. This one closest to this cartilage again, you see this white structure here? That would be the location of the coracoid bar. Again, let us show the pectoral girdle. This one, coracoid bar. So it appears in our plastinated specimen as this white cartilage here. That's the location of the coracoid bar. And originating from it is this chunky muscle here, the common coracoarcual. And then from the common coracoarcual will come this one, the coracomandibular muscle. So just to show you the constrictor muscles again, intermandibularis, interhyoideus, and then deeper to them is the coracomandibular. And this is the common coracoargual. Let's take a look at those muscles in another specimen. So here, I hope you can see. So most superficial is the intermandibularis. And then next to it is the interhyoideus, and this one is the coracomandibular. And then even deeper to the coracomandibular, right there, is the coracohyoid. Let's look at another specimen. So I have here a real formalin preserved shark head. And here, let me just prop it like that. The superficial most muscle that's reflected here is the intermandibularis, the constrictor 1, ventral constrictor 1, intermandibularis again, and there's another layer there, the interhyoideus. From the other side, that's the interhyoideus. I'm touching or reflecting the intermandibularis. And then deeper to them, I'm gonna reflect the two, and you'll see this long and thick muscle. That's the coracomandibularis or coracomandibular muscle, originating from this chunky muscle near the coracoid bar is the common coracoargual. And let's see if we can see the coracohyoid. So again, this is the coracomandibular, common coracoargual, and then deeper, this one is the coracohyoid. And these hypobranchial muscles serve to open the mouth by depressing the mandible. Right? So they're you can say that they're antagonistic to the constrictors, the constrictor muscle, especially the adductor mandibulae, which elevates the jaw. So they're antagonistic. And I guess those are the muscles relevant for our exam, muscles of the shark.